So the point is, the higher potential one, the one having the higher potential E naught is the one that's going to gain electrons. The one that's got the lower E naught that's going to lose electrons. The reason it had the lower E naught was that it wanted to lose electrons, and the reason it had a high E naught was that it wanted to gain electrons. So the current flow would exactly happen in that way, and you get your overall reaction this way. You figure out who's going to gain electrons, who's going to lose electrons. Okay, Vardha, is this clear?
Yep, it's clear.
I said, now the thing is that you don't really need to draw this. Okay, drawing is important because you'll be asked to label this. We did 3 types of electrodes. We did everything related to drawing. There's actually one. I think there's one important thing that we have missed, which is we're doing the electrochemical cell. Let me properly define what electrode potentials are. Okay, like the proper textbook definition of what an electrode potential is. So, where's the so we're going to talk about or define the standard electrode so the standard electrode potential. So this is like our so that's like a formal definition. Now what your standard electrode potential is, by definition, it is the potential difference that's calculated between what? Between is standard electrode and a standard hydrogen electrode. So 2 things. So just a potential difference measured under standard conditions. So you got a standard electrode versus a standard versus a standard hydrogen electrode. Okay, so you calculate the potential difference. Now the thing is that when you're looking for potential differences, like we drew all these electrodes, right? Like we did this Fe3 plus Fe2 plus electrode. I told you that the E naught was 0.77 volts, right? So this 0.77 volts, the value indicates that it's 0.77 volts. Voltage is always compared to something. It's either more positive or more negative compared to something, right? So the voltage is measured with respect to a reference point, which is this. This is known as the earth or the ground or whatever you call it in physics. So every time you've got an electrode and you measure it with respect to something. Now this something is not, I mean, there's no such thing as, I mean, a ground really. It's just a reference point that you take in a circuit. Whenever you measure something, you always measure it with respect to something. When you measure height, you measure it with respect to the sea level or some reference point. Where you measure weight, you measure it with respect to either a 1 kg weight or a 1 pound or 1 stone or whatever. So there's some reference point that you measure it against. So is this clear that for measurements, you always need something to measure it against? So voltages are measured with respect to something. They're either higher than that or lower than that. That something is kind of irrelevant. It doesn't really matter. Like if you measure heights, all the heights of tall buildings from the sea level, the tallest will still be the tallest. If you had taken a different reference point, you'll get different values, but the order would be exactly the same. Like the tallest would still be the tallest. Okay. So is this clear? You need a reference electrode. You've got thousands of electrodes. So what you do is, can't pay what data booklet, just a second. So now what you do is that you've got hundreds, you can make hundreds of electrodes, right? So what you do is you take one electrode, which is used as your reference point. And that one electrode is this one. This is the hydrogen electrode. That is assigned zero potential. Basically, you're not measuring its potential. ठीक है, जैसा height के अंदर ना the sea level is 0 meters, right? Uh, because that's your reference. You're measuring everything against that. ठीक है, so you pick one electrode and you call it your reference point, and all the other potentials are measured with respect to this one. So they're either going to be more positive or more negative compared to this one. ठीक है, Varda, is this point clear?
Yeah, it's clear.
So if I were to measure the potential of this electrode, then it will be, so it's going to be measured against a standard hydrogen electrode, which is probably going to be a gaseous electrode. So you need a gas shower for that. Okay, so I'm going to make this or convert this, forget the C lines. Okay, this is now going to be our reference electrode. The other things, they look fine. Now in the hydrogen electrode, this is the reaction that's going on. It's H+1 gaining electrons in equilibrium with H2 gas. So you got H2 gas in this gas chamber, gas jar, and you've got H+1 aqueous ions in the solution, and that's going to be 1 mole per dm cube. This is going to be at 1 atmosphere pressure. So that's my standard hydrogen electrode. And then here we can, you obviously need a so you need a salt bridge. ठीक है, that's wire connect होगी वहां पे. So you got these two electrodes. This is your Fe3 plus electrode. Now that's your 0.77 volts. While the other one, the hydrogen electrode is your reference electrode. So basically that's 0.00 volts. So what happens is that the voltmeter shows 0.77 volts. That's basically the E0 cell, 0.77. Since you're taking this as your reference, that's going to be the positive 0.7. So that indicates that the iron electrode is basically 0.77 volts, slightly higher potential compared to this one. So every time you're going to do something, you're going to do it with the standard hydrogen electrode. And Okay, so that's, I'm going to label that, that's so that's your that's your standard hydroelectrode. And we've got so basically it's the same electrochemical cell. Basically you just do you measure potential difference with respect to the standard hydroelectrode, and everything should be under standard conditions. ठीक है, clear?
Yep, it's clear.
I said now, so that's all about drawings. Now the next thing is you don't really need to actually do the drawing. TK I mean, if you want to solve something, you don't need the drawing. All you need to know is that the higher potential gains electrons or gets reduced, while the other one, the lower E naught, loses electrons. So that's pretty much the whole concept. So if I pick any two random electrodes, let me just take a snapshot. TK. So if I pick the Fe3 plus, Fe2 plus electrode, that's 0.77 volts. Okay, so I got one. And I pick any other electrode, okay, without the drawing now. Okay, same stuff, but without the drawing. Let's pick the K-4 equation. You get this one. So the simple idea is you got two electrodes. The higher one is the one that's going to gain electrons. So this happens to be my higher one. So that's the one that's going to gain electrons. And the lower one is the one that's going to lose electrons. So this is my lower one. So that's the one that loses electrons. Okay, that's it. That's all you got to do. And you can make up your reaction. The only thing is you would have to multiply the first equation by 5 so that the electrons gain and the electrons gain and loss are equal, right? So that's it. And you'll just add up the reactants. So the reactants in the first one are 5 Fe2 plus. In the second one, the reactant is MnO4 minus 1. Plus 8H plus 1. And then you have your products. In the first one, the product is 5 Fe3 plus. And the product in the second reaction is Mn2 plus. Plus 4H2. Okay, so you get your reaction now. Because that's our overall reaction. Is this clear?
Yep, it's clear.
So that's all you got to do. So I mean, basically, if you know what the electrodes are, you can just make up the reaction. And you can also figure out how feasible the reaction is by measuring the E naught cell. So it's reduction potential minus oxidation potential. So it's 1.52 minus 0.77. That's what do you get for this? That's 23 and 52. That's 0.75. because that kind of tells you how feasible the reaction is. I say, Sitara, you got another. Let's just do one more. Any two random electrodes, TK. We can just do it over here. If I have the, so how do I write on this? So if I have this electrode, the iodine, and I want to figure out the reaction with magnesium, right? So the iodine one is the one that's the higher one. And the other one is the lower one. So the lower one loses electrons and the higher one gains electrons, and that's it. The electrons are already balanced, so you can just add up the reactants. The reactant of the first one is I2, and the second one, the reactant is Mg, and the product is Mg2 plus and 2I minus 1. And the E0 cell for the reaction is, so the E0 cell for this reaction is what it's higher minus lower, so it's 0.54 reduction minus oxidation minus the other one, which is minus 2.38. So क्या I'm going to get, I think, 2.92.
Yeah.
तो ये clear है कि how you're going to do this? Is this clear?
Yep, it's clear.
अच्छा, there's only one issue, which is that you need to know what the electrode. I mean, this is like easy stuff. The higher gains, lower loses. But a lot of times you don't know what the electrode is. Most of the time, the question that you're going to get is just an open-ended question. It's not going to be very specific like this. I mean, these are like very specific, but most of the time your questions will be kind of not that specific. It's just going to be that they'll just tell you, okay, what will happen if copper reacts with FeCl3? So they won't tell you what the electrode is. So what's going to happen if copper solid reacts with FeCl3 aqueous? So you don't know what the electrode is. You know that there is copper. There's something going to happen to copper. That's about it. But if you go and have a look at copper palladium metal, so if you were to have a look at copper, your top here. Now there are actually two reactions where copper is involved. Copper over here could turn into, so there are two electrode reactions. Copper could either turn into copper plus 1 or it could either turn into copper 2 plus. So you don't know which electrode to use. Okay? So you have no idea what can happen. The same with the Fe3 plus. FeCl3 has Fe3 plus. So Fe3 plus, you don't know whether it's going to gain 3 electrons to form Fe, or it's going to gain 1 electron to form Fe2 plus. So that's also you're not sure which electrode to use. Since it was FeCl3, so you also had Cl minus 1. So you had Cl minus 1 turning into Cl2. You got Cl minus 1 over here as well. So you got Cl minus 1. So you don't know what's going to happen to it as well. So the point is that now you got multiple electrodes possible, which can be used for this reaction. Now, the way you're going to do this is, these are the steps. Okay, step number 1 is identify your reactants. Now, how do you identify your reactants? you have to treat ions as separate species. So you got Fe3 plus, and you got Cl minus 1. So these three are your reactants. Second one, step number 2. That's more important. Step number 2 is you're not just going to go with 2 electrodes. You're going to consider all electrodes. So write down, or since you're not going to write it down because you'll have the reactions in front of you, you'll just mark them. So write down or mark all electrode reactions that involve your reactants. So I'm going to start writing them down. For copper, I had 2, like I had copper plus 1, gaining 1 electron in equilibrium with copper. I had another one, which was copper plus 2. So for copper, I had 2. For Fe3 plus, TK in the data booklet, I also had 2. I had Fe3 plus in equilibrium with 3 electrons. So there was 1 electrode which was doing this, forming Fe. There was another one which was Fe3 plus, gaining just 1 electron. And that would form Fe2 plus. And then for Cl minus 1, I had this one, which was Cl2 plus. I think this was 1.36 volts. This one over here was this one was 0. So the Fe3 plus equation. Where's the Fe? The Fe3 plus with 3 electrons, that was minus 0.04. And the first one, which was copper plus 1. So that was 0.52. So I wrote down all electrode reactions that involved, whether they're on the right side or on the left side, it doesn't really matter. If they're on the left side, then they would gain electrons. If they're on the right side, they're going to lose electrons. We don't know what's going to happen to them. I had Cl minus 1. So these are my, so anywhere, whether the reactants are on the right side or left side, we don't care. So for Cl minus 1, I ignored one of the reactions. Why? I mean, this one. For Cl minus 1, I ignored this reaction, and the reason was ye wala. Ek second. So the reason I ignored this reaction was because Cl minus 1 had OH ions reacting with it. I don't have OH ions as my reactants. So since I don't have OH ions, so this electrode reaction is not possible in my case because I got no OH ions. Okay. Varda, ye clear?
Yep, it's clear.
So, but otherwise, I wrote down all the reactions that I found here. Now, step number 3 is the same one, which is the highest one, the highest potential. So out of all these possible reactions, who's going to gain electrons? The one that's got the highest E naught. So highest E naught gains electrons, and the lowest one out of all of them is the one that's going to lose electrons. But you have to make sure that so you have to make sure that your reactants they lose or gain electrons. I mean, it has to be one of these 3. I mean, nothing from outside. Like if so it has to be one of these three. So who's the highest potential out of all of these? कौन सा इनमें से? Who's got the greatest tendency to actually gain electrons?
Is it Fe3 plus?
Need the highest potential. Which one is the highest?
Oh, Cl minus.
So that's going to gain electrons, right? So it's going to go in the forward direction, right? So it is the highest, right? But who's gaining electrons? It's Cl2 that's gaining electrons, right? You don't have Cl2 in your reactant. So although that's got the greatest tendency to actually gain electrons, but I mean that's not applicable to your reaction because you don't really have Cl2, okay? So I got rid of it, okay? You clear?
It's clear.
I'm just going to ignore that, okay? So now who's the highest one? That's the Fe3 plus one, right? So that's the one that's going to gain electrons, right? So who's gaining electrons? It's Fe3 plus. We do have Fe3 plus. That means that's fine. That's applicable to our reaction, right? So I figured out my substance that's going to gain electrons, and then I'm going to figure out the one that's got the lowest potential. Lowest at the moment is this one minus 0.04. So that's the one that's going to lose electrons. But again, I don't really have Fe. I mean, there's no Fe over here. So I'm just going to ignore this one. Okay, it's not applicable to my reaction. So who's the lowest now? The lowest is 0.34. So copper is the one that's going to lose electrons, and I do have copper over here. So so I've figured out who gains electrons, and I've figured out who loses electrons. और इसको बस highlight कर लेते हैं कि so I have this reaction, and I have this reaction. ठीक है? ये clear?
Yes, clear.
And we can just balance the equations and add up the overall reaction will be in the first one, the lowest one, it's copper. That's the reactant, so it's going to be copper. Plus in the second one, it's Fe3 plus. But it's going to be 2 Fe3 plus because I need to make the electrons lost and gain equal. And my products are going to be, I say in the first one, the product is copper plus 2. And in the second one, it's going to be Fe2 plus, 2 Fe2 plus. अच्छा तो ये मेरे पास reaction आ गया. So is this clear how to do an open-ended question where you don't know what the electrodes are? So you're going to write all possible. You're going to identify the species. If it's an ionic compound, treat ions as different species. If it's NaCl, and you have to write an equation for Na plus 1. The other one would be Cl minus 1. And then you just have to find out all possible electrode reactions that involve your reactants. Find out the highest one, the lowest one. Just make sure that you're going to select the highest one that you have as your reactants. Okay? Ignore any other high. If you're getting any other highest option, then ignore that if it's not your reactant. Okay? तो ये clear है? सारा clear है?
It's clear.
So whether try and do this question. Units. So let's say I've got SnCl2 and I'm going to react it with K2Cr2O7. And it's acidified. ठीक है, so do you have the data booklet? Like you can just Google 9701 data booklet. There's going to be electrode values in this.
Okay.
But just Google it or maybe write PDF next to it. Asha, so this one, try doing this one. The species that you have are SN2 plus. You've got Cl minus one. You've got K plus one, K2Cr2O7. You got dichromate 6 ions, Cr2O7. And you've got H plus one. So write down, so SN2 plus, find out where SN2 plus is. SN2 plus is going to be on the next page. So there is SN2 plus, one electrode involving SN2 plus, the other one as well. In one of them, it's gaining electrons to form SN, and the other one is losing electrons to form SN4 plus. Then you've got Cl minus one. So Cl minus one is over here, and I'm going to use this one. Not this one because there is no alkali, so we're going to ignore that. Then it's K2Cr2O7, so it's K plus one, which is K plus one is here. And Cr2O7 2 minus acidified means that you had H plus one ions in the electrode reaction as well. And I guess that's it. So these are all your reactions, ठीक है? तो इसको जरा करो ना, try solving this one, ठीक है? Just Google the data booklet, download it, and have you found the data booklet?
No, I haven't found it.
ठीक है, then I'll send it on WhatsApp as well.
Yeah, I found it online.
ठीक है.